session 0 on Apache Storm. And before going to start this session, I will introduce myself. I will say a little bit about me. So my name is Dilip, and uh, yeah, my name is Dilip. I have working on Apache Storm from last 2 years. I started my career as an Hadoop developer. So uh, from last 1.5 to 2 years, I am working on this Apache Storm applications. Right now, I moved to machine learning. So we will see how this Apache Storm is useful in real time and what are the advantages we are going to have while once we move to big data for Apache Storm. Yeah, in this session, we are going to see introduce what is Apache Storm, and the next thing is we will know the little bit thing history of Apache Storm. The next thing is we will see how the architecture is made, and we will see the differences between Apache Storm and Hadoop. The next is we will go through the basic terminologies, and we will wind up the session with the course content and hardware requirements that needed to run Apache Storm in our local as well as in production cluster. So before going to know about this Apache Storm, we have to know what is Hadoop. Because no real-time framework or no real-time data, there is no framework that deals with the real-time data. All we have is Hadoop. The reason before Hadoop also we have to write our own codes, our own applications to perform some aggregations, filters on the data what we are getting to an industry or any social networking data. But when the Hadoop came into the existence, that entire processing system has the latency, the time taking of the processing of huge amount of data went down, and that's why we are using Hadoop became famous within short period of time. So but uh, we already have the Hadoop, but why we are looking at this Apache Storm? So the reason is Hadoop is something that works on the batch processing system. That means we have to store our data at some time, at somewhere in the hard disk or some our DBs, and we perform whatever analytics we want, and we perform jobs on that particular data. That Hadoop jobs runs for once in a while. That means we have to automate them. Okay, before knowing moving to the Storm, we have to know basic things about this Hadoop. So how the Hadoop framework works, how that Hadoop manages the data, what type of functions are used within Hadoop. I will show in within short sentences. So when we look at the Hadoop architecture framework works with MapReduce workflow. All we find in Hadoop is some mappers and some reducer. We perform some aggregations like filtering, and we found some partitioner, combiner in between mapper and the reducer. So whatever happens, whatever we code, whatever we do, we just make use of these classes or this particular API, and we develop the Hadoop jobs. So why I'm saying this, we have to remember that within Hadoop, while we are working, we will just go through, look at the mappers, and we eventually at the end we will look at the reducers. Reducers are the output whatever we want. The reducers push the output. We store that output to some DBs and wherever we want. So the only thing we find in a Hadoop is the mapper and the reducer, two classes, and the entire process we call as an Hadoop job, and this entire process will be taken care of the driver. I'm saying the developers who is having an idea on Hadoop can understand this workflow. If you are newbie to this session, just try to remember this. All we find in Hadoop is is just a mapper class, and the reducer class. Mapper class is nothing but our input splits from where we read the data, and the reducer is something that we the required output that we want to see at the end of our processing. So the Hadoop Apache Storm also follows same kind of thing. This same kind of workflow only, but it is an real time work. So what is an Apache Storm? It is a real time data. So it is a stream based one. What is stream based? As I said earlier, when we see Hadoop architecture, it is in a batch process. What is difference between batch process and the stream based one? Batch process is nothing but we will store our data somewhere else, and at some particular of time we will process that data, huge amount of data. We perform some batch works on that particular data. So when it comes to streams, the data will be flowing in the sense the data will be coming like a flow. So there is no stop that to particular data. So some real-time data we can't store that real-time data. For example, if you want to analyze the real-time data like traffic navigations, so now IoT of things. So we get traffic data or without any breaks. It's just like a flow. So we have to handle that type of data. We have to perform our analytics on that type of data. So we need something to perform that work will be done by this Apache Storm. That's why we are saying this is a stream based one. So the next thing is it is fault tolerant and non-persistence. What is fault tolerant? So guys, if you have an idea on what is Hadoop, how it works means, you have to know, I think you have studied Hadoop also is a fault tolerant one. So what really means this fault tolerant means? So fault tolerant is nothing but when a mission fails, automatically it have to reschedule work to another mission. So in an entire cluster, we used to have group of missions, and they distribute work among themselves. And if someone fails, immediately it should not stop working over there. It should distribute its work to some other VM until this VM was up and running. The next point is it is now non-persistent. As I said earlier, in Hadoop we are going to store the data, and we are going to perform the analysis whatever we want, or analytics whatever we want, or some ETL perform ETL changes whatever we want on that stored data. But when it comes to Apache Storm, we are not storing our data anywhere. We are just directly picking up from the point where we are getting the data, and we are just making the changes whatever we required on fly, and we are throwing it onto our DBs wherever we want to store that particular thing. The next thing is it is an Apache incubator project. It is written in Clojure and Java. So incubator project means I have to know it will have wide range of development. Once it is joined in Apache incubator, we can see wide range of development within that project, and it is easy to understand because it is written in Java as well as Clojure. Initially it was written in Clojure, but now everyone is developing Storm in Java with Java only, and it was released with an Eclipse license. So we will know a little bit history on that. What is the history of Apache Storm, when it is started, and who is the person introduced Apache Storm to us. So here is history. The person you are seeing at the right in the picture is the Nathan Mas. He was the person who introduced us the Storm. He used to have a social analytics company. So in that company with his team, he developed Apache Storm. Later it was acquired by Twitter. So Twitter bought that analytics company. The name of the analytics company is nothing but Backtype. After Twitter bought it, made some changes. It used it for its project. Next, at the end, it made it as an open source in 2011. Next thing is the Apache added that to his incubation center in 2013. So this person was not currently working on the development of Apache Storm framework. He is working on some other framework right now. So you can find this person in Twitter also. If you want, you can check him. His name is Nathan Mas. You can Google about him on Google. He will be available, and if you have any doubts regarding to Apache Storm, he can give an idea on Apache Storm, but he cannot clear your doubts right now. Why? Because he just moved to another project. So this little bit of history is enough about Apache Storm, and we will look at the architecture. So as I said earlier, we have to know Hadoop architecture before knowing the Storm architecture. If you're a newbie, guys, you're gonna learn for the first time means don't worry, you're gonna learn it easily. So if you're a Hadoop person, you will understand it very easily. So the picture what you see in the right side in the blue color is that that architecture is a MR1 architecture, and in whatever you see in the left side in the green color, that is MR2 architecture, Hadoop 1 and Hadoop 2. So in Hadoop 1 we used to have the name node. Eventually name node consists of master and job trackers, and we have some slave nodes. So when it comes to Hadoop, the difference is the resource manager came in the middle, and it started distributing the work to the name master nodes as well as the name nodes. The only difference between Hadoop 1 and Hadoop 2 is we have a resource manager in between, and resource manager will take care of the jobs whatever we are deploying in the cluster. So if you have an idea, try to remember this. We have a name node and slave nodes. This Hadoop architecture follows master and slave architecture. That means master will be taking care of the jobs what we have to run, and slaves will be doing that particular jobs. Okay, and the next thing is Storm. Storm also follows the same kind of architecture, master and slave architecture. In Hadoop, we seen that we have a master node and a slave node. Similarly, in Storm also we have Nimbus. Nimbus is nothing but the master node. It takes the application, whatever work should be done, it will be taken care of Nimbus, and work is distributed to supervisors, and they will be working as an slaves. So in between, we use Zookeeper as a coordinator service between Storm Nimbus and the supervisor. So this is a simple architecture, guys. We have Nimbus, we have Zookeeper for coordination purpose, and we have supervisors which perform the job assigned by the Nimbus. This is just like in Hadoop we have master nodes. Master nodes will be having what type of work should be done on. Will be having that particular record what type of should work be done given to the data nodes. That means slave nodes will be doing that particular job, and they are going to complete it, and they are going to give back that give a response back that we have completed, and again the master node will be assigning another job to it. Similarly, in Storm also we have a Nimbus node. It is a master node, and we have supervisor nodes. They perform the supervising tasks, so they perform the jobs, they will end up the jobs, and they will give acknowledgement back to the Nimbus. And in between we make use of Zookeeper. Zookeeper does nothing but it coordinates between it give coordinate services between Nimbus and the supervisor. Hope you got that architecture. So okay, fine. We came to know what are the what are the daemons that run in the Storm cluster. So what are the jobs we run on Storm cluster? So type of jobs means in Hadoop we used to deploy the MapReduce jobs on master node. So similarly in Apache Storm we are going to deploy topologies. Topology is nothing but they are just like our MapReduce jobs, which is written for real-time analytics purpose. Real-time, it processes the real-time data. Topology contains nothing but we have some sources, and that sources emit streams of data. That stream of data contains tuples, These tuples are bolted together by a bolt. This is a bolt, and from data where we get is spouts. We call this, you can see here, tap. This is a spout. From this is the point from where we are getting the data, and it emits the data like a stream format, unbounded format, and we are going to get that as an we are going to see that stream as an tuple. These tuples are given to bolts. As in Hadoop, whatever we are doing, we are deploying our application on a master node. The master node contains after deploying the application contains mapper class. That mapper class will perform some sorting, filtering kind of things in between, and finally it gives back to the reducer. Reducer is nothing but our final output where we want to store what we want to see. Similarly, we have emitting the source emitting, and we get tuples from that. These tuples are given to back to the bolts. So these bolts perform some logical operations whatever we want, and it give back to the bolt. From that bolt we can, if you want to directly save into our DBs, or we want to see somewhere else, we can store that our output to back to the tuples only. So hope you got this. So this is a spout. Whatever you see in the tap is a spout that emits the data for us like a stream format. That is a flowing data. It's not going to break anywhere, and that stream contains tuples, and these tuples are given to the bolts, as we are giving mapper functions to some partitioners like that. And these bolts perform some logical operations. It give back to another bolt. This bolt may be our kind of our reducer if you compare with the Hadoop. So this is a final reducer, and this final reducer writes our final output to our DBs or somewhere else, wherever we want. So Storm versus Hadoop. Right till now, I'm saying that Storm just looks like Hadoop. So how come Storm looks like Hadoop? What is the difference between Storm and Hadoop? We will see. So Hadoop, when it comes to Hadoop, Hadoop is a distributed and fault tolerant. I already said what is fault tolerant, what is distributed. Distributed in the sense, when we don't have Hadoop kind of thing, people used to deploy their own applications for performing some filterings on their data, whatever they are getting. So it used to take some days of time. It is some months of time, 6 to 7 months of time. So even though it is a time-taking process, they used to develop the applications, and they used to deploy to perform some processing, filtering on the data, whatever they are getting. And the next thing is where it takes the first drawback is they will take much of time for developing it. The next thing is they used to deploy it on different servers. So if they have 1 GB of data today, they used to get 2 to 3 GB of data after within 3 to 4 months. So at that time they used to add one more VM. They used to add the same application to that VM, and they used to deploy same application, and they used to process the data whatever they got within this 2 months of time, which is something not the distributed kind of thing. But with the existence of Hadoop, it is distributed. That means we will deploy the final whatever application we developed in Hadoop MapReduce, we will deploy it at once, and all we need to do is we need to increase the VMs. If the data flow is more for for us, we used to increase the VMs. Otherwise, we will deploy the job only at once. While starting time, we will deploy the job on master node. Master node will be taking care for distributing this job to all the slave nodes. Hope you got what is distributed. And the next thing is fault tolerant. I already explained about fault tolerant. If some VM fails while processing the data, automatically it distributes the work to another supervisor or another slave node within the job. It is a batch process and file based. So I already explained batch processing means we have some huge amount of data. We will split that data into batches, some batches, and we perform our jobs on that particular batches. So Hadoop follows master and slave architecture only with the zookeeper. Uh, at the starting, I already explained how to has a master node and it has some slates. So we did not saw that zookeeper kind of thing. It will be the outside VM. It will be coordinating. It will also use as an coordinate service between this master node and slave nodes. Persistent and uses HDFS. So I said persistence means we have to store data somewhere else. Data should be existing somewhere else to perform some particular kind of job. So that place is nothing but HDFS. In Hadoop, we used to store everything, whatever data we got, we used to store everything that in HDFS, Hadoop distributed file system. And finally, Hadoop user for big data analytics. So we perform this Hadoop jobs on big data in the sense huge amount of data. Big data have different meaning for that. And we use Hadoop for analytics purpose. Similarly, Storm also distributed and fault tolerant. It is real time and stream based. The only difference is it is real time. So we are going to get the data immediately. We are going to process whatever the requirement we want. The logic we are going to implement on that particular data immediately. Within seconds within seconds of time, we can show that output whatever we done by receiving that data. I will tell you the use cases also where we are using in real time. It is a stream based. So Hadoop is an batch process and file based. This is an real time process and stream based. The next thing is it follows master and slave architectures. Similar kind of thing I already explained you. It is non-persistent. That means we are not going to store the data anywhere. Once we deploy the Hadoop clusters and we are not going to see the data, that means like a HDFS kind of thing, but some place to store the data and to push that data to our framework, that topology, Storm jobs. The final thing is it is also used for big data analytics only. Guys, Hadoop is a batch process and this is a real-time process. Real-time process means we get streams of data. Within seconds, we are going to perform the analytics, whatever we want on the data we are getting. But Hadoop takes time. We need to collect some amount of data and we used to run that a map job, Hadoop job, and after some time, that sometime maybe minutes time, hours time, after that only we are going to see the output. But when it comes to Apache Storm, we will get the data right now. We will do whatever logic, we will perform whatever logics we want. Sorry, whatever logics we want, and immediately we will store back to we will store back our DBs and as in real-time analytics. At the end, I will show you the real-time analytics, how it is performed in real time. The next thing is Hadoop versus Storm. So they are complementary technologies. The only thing is Hadoop used for batch processing and Storm used for real-time processing. Uh, we can use both of them in a single system. That we have a single system. No, there is no problem using Hadoop and Storm in a single system. We don't get any errors. Storm is used to process only streaming and real-time data. Hadoop is used to batch process and it is persistent data will be available on HDFS. It will take the data available on HDFS and it will be from the jobs. But when it comes to Storm, we are not going to store the data anywhere. We are directly taking from the source point and we are performing the logics whatever we want and we are pushing to our DBs as a final output. So what are the terminologies we are going to? So once we started, so right now we are in the intro session of Storm. So if you want to go for Storm framework, what are the terminology you are going to see? So if you are already working on Hadoop, means Hadoop has terminology like master node, slave node, zookeeper, mapper, reducer, combiner, partitioner. While developing side as well as an cluster admin side. We will hear this kind of terminologies once we are working on a Hadoop environment. But when it comes to Storm environment, what type of terms we hear daily? So these are the terms. tuple, stream, spout, bolt, nimbus, supervisor, and topologies. So we will know what is. So I already explained you, but I will explain you this in little bit with a clarity. Tuple. So I already said we get streams of data from this particular part. This is nothing but the spout from where this here from here we are going to get the data. This is the point where we are going to pick the data and we perform the analytics. We call this as an spout. So the next thing is spout emits streams of data. That stream is nothing but unbounded feed of tuples. That means the stream contains tuples. Tuple is nothing but ordered pair of elements. So VT has some order tuple ID plus the message whatever we are sending in the particular stream. The next thing is we have bolts. Bolts is nothing but we are going to perform some logical operation within the bolts. We are going to filter the data whatever we are getting in within the bolts, and finally it works as a. Finally, we will store it back to our DBs. So when we see Hadoop jobs, you have mapper jobs, reducer jobs, partitioners in between, and the entire job we have one final class which is called as driver class, that is a main class. Similarly, we have in Storm also we have this Storm spouts, bolts. We should have some one main class, one main class from where we can execute the spouts and bolts. That is nothing but the topologies. Within topology only we are going to combine the spouts and bolts, from which spout from which bolt it should go, from which bolt to which spout, which bolt it should receive again back, and from where we have going to perform that logical operations. All things will be given within here topology purpose. This you can see this architecture will be just like a ETL kind of architecture. That means ETL nothing but extraction, transform, and loading. That means we will extract the data from our source point. We will apply some filters or some joins, some aggregations, whatever we want within the bolt, and finally we will load that final output to our DBs. So we call this the entire thing what structure will be written in this topologies. The next thing is Nimbus. As I said earlier, Nimbus is nothing but the master node. Just like in the Hadoop architecture, we use master node. Similarly, we use Nimbus in the supervisor architecture. Supervisor is a slave node. Just in Hadoop, we have slave nodes that performs the work. Similarly, in supervisor, we have this. We perform that particular jobs, filtering bolts, whatever you want. That task will be done. The bolt performance will be going on within supervisor. So some pre-queries. So we are done with these terminologies. We are done with the architecture. We are done with the history. So we are done with what is an Apache Storm. So now what are the pre-queries that we required to learn job, to learn the Apache Storm? We need only Java, and we have to know about Linux, some idea on Linux, or some basic idea on Java. So if you have these things, you can turn into a developer as well as an Hadoop administrator. The next thing is applications, real-time applications. Storm is used in machine learning. We can use machine learning in Storm. We can do some real-time analytics. We can use this Storm as an ETL purpose. So I used this Apache Storm as in my projects. I use it in Apache Storm for machine learning purpose. I use it Storm for ETL purpose. I use it Storm for real-time analytics too. As I said earlier, I will show what is real-time analytics, whatever we are getting here. See, if you have Twitter, in Twitter we do some tweets every day. So if you see your tweets here we can see some favorite retweet and like. Similarly, we can see tweet activity. So how actively our tweet is going through the world, reaching to the world. So when we click at this, you can see some impressions. Sorry, just a second. Yeah, I will show you one more tweet. I think something wrong with this. Yeah, this one. This sentence. Why? Just a second, guys. It shows some analytics right here, but I don't know why it is showing like this right now. Impression counts. It shows some impression counts here. Yeah. When you have time, please click at this thing. I don't know why it is not coming right for right now. Please view for your tweet activity. What Twitter does is here, Twitter keeps on monitoring your tweets and the link clicks, whatever you are getting on your tweet. So just I'm going to my tweet and I'm clicking like this. So this means someone has seen my tweet. So someone may favorite my tweet, someone may retweet my tweet. So like this, I'm going to get some kind of impressions, engagements, and total likes. So they have to keep on monitoring my tweet from which stage to which stage it is reaching. So how many people has seen that tweet, how many clicks I got on that particular tweet. This kind of tweets I should get this type of analytics. Twitter uses Storm for performing this type of analytics. So right now I am unable to see here this analytics kind of thing. So if you have a Twitter account, please go into Twitter account. You just look at that tweet activity you made, and you can find these counts here. So you can see counts here. These counts are monitored, are done by the Storm only. So Storm will perform how many link clicks I got, how many likes I got, how many retweets I got, and it performs. It formulates. It uses some formula, and it make count. It will show these counts to us: impression counts, total engagements, likes. Okay. This is how we use. This is how we use Apache Storm in real time for our purpose also. So if you ask about my experience, I really enjoyed writing Storm applications while working with machine learning. I got a task like that. I need to get the tweet of a particular person and immediately I have to do sentiment on that. I have keep monitoring him and I have to give a report on him, what kind of impression he has on Twitter, social media. So I have to perform some machine learning tasks like finding his positivity or negativity with by the tweets, whatever he are getting, by the tweets he is making. So I need to collect all those tweets immediately. I have to show that tweets to him, show the negativity to show that real-time analytics to him. So yeah, I really enjoyed while developing that kind of stuff with Apache Storm. Yeah, thank you. This is a final slide. The next thing is so what we are going to learn throughout this session. I will show you what we are going to learn throughout this session. So this is how. Now for today we are done with getting started session 0. So once we started the regular classes, we will go through once again with Apache Storm. We are done with all the tasks. Once we started the regular classes, we will go with basic Linux. The next thing is we will go after Linux. We will go to Java. So guys, if you have an experience on Linux as well as Java, we will skip that too within one day of time. And we will directly move to cluster setup. So we are going to set up a cluster within our local for testing purpose within our local systems and as well as the production setup. So how we are going to set up the cluster in the production. So once we set up the cluster, we will go through Storm UI as we have Hadoop UI for monitoring our master and slave nodes, job trackers and task trackers. Similarly, we have Storm UI for monitoring our Nimbus and supervisors, for monitoring our topologies, goals, We will go through it overview. I will tell the overview on that. The next thing is we will start the developing part. Once we are done with it, the cluster setup part, we directly move into the developing part using Java. Using Java API, we will move developing spouts, bolts, and I'm going to explain about what are the interfaces we have in this API. That means Storm API. I will explain you what are the methods. Next, we will see what example topologies. Next, we will see about types of groupings. Groupings are nothing but some kind of operations we need to perform at to particular for performing some tasks within the Storm and within bolt to bolt. So I will clearly explain you how many types of groupings we use on Apache Storm, and as a guarantee message processing, how Storm is guarantee message processing. I will give an overview on that, just a short description for a better idea how Storm processes the tuples without fail. So the next thing is we will see some overview on Trident. We will perform some topologies we will develop on Trident as well as Storm. And the next thing is we will install Kafka. From Kafka spout, we will read the data and we develop Kafka topology. So for the installations, we will see Kafka installations also, how Kafka works, how Kafka and Storm combinedly work. We will see during that time. Finally, I will wind up this entire course by giving you the real world applications. Uh, Either I will perform that real world applications, otherwise I will give tasks for you once you are done with this above development stage. And now I can say finally, thank you.